Hello, everyone. In this video, we're going to begin section 14.3 on local linearity and the differential. So in this section, we're going to meet a really important object called the tangent plane of a multivariable function. So just like in Calc 1 or differential calculus, if we had a curve, a function of just one variable, then we looked at taking a tangent line to that curve. So in two variables, if we're looking at a surface, so a function is given to us as a surface, then we might want to approximate that surface near a point. And so in that approximation, rather than a line like we got in one dimensions, we're going to get a two-dimensional flat plane. All right. So let's call this surface here our function f. And here we have our x and y and z coordinates. So if we pick a point here, say AB, and we get an output on our function, then we can consider how that function f varies in the x and the y direction around that point. This is just like what we did in the previous section. So let's label a few more things. So here's, say, our point AB. And so here we see this plane looks very close to what that surface is. And it's kind of hanging off the surface, but if we have to use a plane to fit that surface best, we'd see that it's this plane here given in our drawing. Okay, so how would we write the equation of that tangent plane to our surface Z? And so here we're looking at a surface Z and the point AB and the output f of AB. And so that equation is given to us as follows. Z equals f of AB plus m times x minus a plus n times y minus b. So if you recently took Calc 3, and in particular, if you took it with me recently, we've actually seen this equation before. This looks very similar to an equation of a line that we've met before. In the notation that you might have seen, this f of AB we called z naught, this a we called x naught, this b we called y naught. And so just to recall, or maybe to remind you, or maybe if this is the first time hearing it, the m is going to be the slope of that plane in the x direction, and the n is the slope of the plane in the y direction. And in fact, for a tangent plane, we've already met these slopes in the x and y direction. In fact, that slope of the plane in the x direction is just the partial derivative with respect to x. So m is f sub x of AB, and n is f sub y AB. So if we're looking at our point AB, f of AB, and we look at how that function changes in the x direction, then we're going to be looking at a line here that approximates our function. So something like this. So we can call that line, say L1, like we saw before. There you go, L1. And then similarly, if we look at varying our function in the y direction, we get a line here that approximates our surface. We'll call that L2. So this f sub x of AB is the slope of L1. F sub y of AB is the slope of L2. And so then to summarize, the tangent plane is going to be the plane that contains the two lines that go through our point AB, f of AB, in the directions of the way that our function changes with respect to x and y. All right, so now let's look at this next box. So the tangent plane approximation to f of x for xy near the point AB. So this might seem a little weird that a plane is approximating our surface, but I want you to think about the surface of our Earth. So our Earth is a round sphere, approximately. And if you're in the middle of the ocean, it kind of looks like you're just sitting on a plane. So as you zoom in to your surface, what it's going to look like is approximately a plane. And so we can use that plane to approximate what the values of f are near a given point, AB, f of AB. So we can kind of use that plane instead of our function if we want to approximate what the function values are. And that's just exactly what this box says. So it says f of xy is about equal to the value of the plane at the point xy. And so we see this is just what we were discussing about the slopes in the x and y direction. We see that partial with respect to x here, partial with respect to y here, evaluated at that AB point. And so this is what we can use, this equation is what we can use to approximate our function at a point near AB. All right, so in the next examples, we are going to look at how to find some equations of tangent planes.